Larry Bartoszek, thank you so much for taking some time to be with us this afternoon. For our listeners, please just open up by sharing a little bit about who you are and what it is that you love about space.
Well, my name is Larry Bartoszek. I have always been interested in space. I was a Star Trek fan for the original series back in 1963, I believe. I'm a mechanical engineer. I used to work at Fermilab from 83 to 93 and helped build the anti-proton source there. And in 90, I started my own business, Bartoszek Engineering, and I've been a mechanical engineering consultant full time since 93. I did it part time between 90 and 93 and just worked 24 hours a day.
That's awesome. I think the Sheldon Cooper in me wants to remind you that you are a physicist. You are also a physicist. Is that correct? Who masquerades as an engineer with a company?
You can't really be a physicist without a PhD. I have two
Oh,
bachelor's degrees, one in mechanical engineering and one in physics.
excellent. So not only do you understand how the universe works, but you can build any device to measure or study it.
I'm going to get right to the space elevator question. I know that as I was looking at, your bio today, I was going, what is this? And for, my mind, that's not nearly as scientific as both yours or Kevin. All I can imagine is this going to be a way that we can ultimately access space?
All right, very simple. A space elevator is literally a ladder out of the atmosphere. It's a cable that connects the ground, a tether all the way through geosynchronous orbit out to 100,000 kilometers. And I've been designing since 2004. I've been doing conceptual designs for climbers, which are electric vehicles that roll up the ribbon out into space.
So once you got above the stratosphere, you could be solar powered, could you not? At least if you were moving in daylight, or do you just halt at nighttime, or do you use some other sort of propulsion?
Believe it or not, there are a lot of people in the International Space Elevator Consortium, several people anyway, who thought that a solar powered climber was the way to do it. I am not in that camp because a commercial climber will be anywhere from 4 megawatts to 11 megawatts of power needed to get off the Earth at a reasonable speed. And you just can't have solar cells large enough. They're not practical. So no, I'm of the camp that there will be 10-meter diameter laser arrays
Mm.
on the ocean platform that will be delivering power to the climbers by laser.
I've actually shown some students some prototype videos where they had a tether on a crane and they used a laser to provide the energy for the motor upwards. I actually have seen some prototype videos.
Yeah.
You mentioned the ocean platform. Explain to our listeners why the base needs to be maybe a little bit flexible in its location.
So one of the challenges, and it has gotten much more challenging in recent years with Elon Musk's 40,000 satellites in low Earth orbit for the Starlink system. There are lots of things in low Earth orbit, and anything in low Earth orbit is going to move through the point that the space elevator goes through at some point. The International Space Station will eventually cross the point where the space elevator is. So one of the ideas for avoiding orbits in low Earth orbit is you move the base of the elevator back and forth, and it will induce a transverse wave that will allow the tether to miss whatever is in orbit passing through that point.
So you set up a standing wave, uh,
Not necessarily a standing wave, a traveling wave.
a traveling wave, because you're free end out there in space. That's outstanding. I got to go right to the how do we manufacture an apparatus that extends for 100,000 kilometers? How do we manufacture it in space, or do we manufacture it on the ground? What,
That's a
or both?
really it's a really good question because it kind of depends on what the material is. Um, you need a rocket to boost a spool of the material up. And back in 2003, when Brad Edwards wrote the book on the space elevator, he was assuming that there would be spools of carbon nanotubes that would be possible to boost up on the space shuttle. He designed everything that to fit in the cargo bay of the space shuttle. So his idea was you put a pilot ribbon up, and the pilot ribbon is very small, and it's only like 40 tons worth of carbon nanotubes, and you allow small climbers, 900 kilogram climbers, to climb up it with more material, adding material as you go. And that technique seems to work very well for carbon nanotube fabrics. I'm not so sure it works for graphene fabrics. And here's the thing. Back in 2004, we all thought carbon nanotubes, and of course there's the technology hype cycle.
Yes.
And when they weren't able to grow carbon nanotubes long enough, the hype for carbon nanotubes has gone down, and now we're in the graphene hype cycle.
Okay.
But we're having similar issues growing single crystal graphene long enough and strong enough. What happens if you make it big enough is it becomes polycrystalline. And once you have grain boundaries in the material, you have weaknesses. And it doesn't develop the strength necessary to be space elevator fabric. So that's a question as to whether or not you would actually do some carbon fabrication in space with nanotechnology.
So again, as from the layperson's perspective, right, trying to even envision what this would look like and for what purpose, what would the space elevator be taking? Is it taking up people? Is it taking up items that are needed out, at the space station? And ultimately too, why is it better than what we have now? Is it cheaper in the long run? Like what's the pro for that?
So the problem with rockets is that rockets are completely controlled by the rocket equation. And a Saturn V rocket put a tiny percentage of the total weight of the rocket on the moon. It could put a larger percentage of its mass in low Earth orbit and a lesser percentage in geosynchronous orbit, but it is always, always, always governed by the rocket equation because it has to throw mass out the back to lift. The space elevator is not limited by the rocket equation because we don't carry the fuel on board. If you're pumping laser light from the ground, it doesn't matter how big the ground facility is or exactly what the efficiency of the powered beaming system is. You can make it as big as you need it to be on the ground, and then it's converted at the altitude of the climber. So the idea is you can go from $25,000 a kilogram, which was roughly the cost during the space shuttle era, to $250 a kilogram in the space elevator era. Now, would you take people up there? Not for the first few decades, because the trip takes a week to get from the surface of the Earth to the altitude of geosynchronous orbit. And it's passing through the Van Allen radiation belts. And you're only going a couple of 100 kilometers an hour through the Van Allen radiation belts. The only human beings on the planet who have ever gone through the Van Allen radiation belts are the Apollo astronauts. And there was a solar flare, I believe, during Apollo 14, where they received the highest dose from going through the Van Allen radiation belts of any of the other Apollo astronauts. Spending a week in the Van Allen radiation belts would be very bad for you unless you had an enormous weight of radiation shielding. So the elevator basically takes too long and is too slow for people. It's a cargo elevator.
Wow. You hit on about 5 really cool things I want to circle back to. Number one of the first people ever that we've spoken with on our podcast that mentioned the Gartner hype cycles. And you mentioned that nanotubes had hit the trough of, disillusionment or something, where they, there's all this initial hype. And then for our listeners, your nascent technology just can't be either commercialized or made practical fast enough for those early adopters. Right. And so that's number one. Number two, you're absolutely right. If I'm not mistaken, the Saturn V was about 93% by weight fuel. And that's chemical rockets are horribly inefficient, right? Very inefficient.
And not only that, you could, if you powered the thing with, say, either space solar power, where you have satellites beaming microwaves to Earth, converting it back into electricity. If you did that, that's a very green technology. From my perspective, even powering the lasers on the ground from a submarine nuclear reactor is perfectly green. We just
Right.
have to get better at our fission technology.
Absolutely. Absolutely. So here's a great question. How did you, let's circle back. You spent a decade at the Fermi Lab. You got to have about 100 stories, some of which are probably unclassified. Tell us about the day in the life of an engineer at the Fermi National Labs.
Well, everything we did at Fermilab is unclassified. At the time,
Okay.
Fermilab, and it's still one of the only single mission laboratories. The national laboratories like Argonne do have classified work going on. They do have guards who carry guns because they have nuclear materials and nuclear reactors. Fermilab is not like that, and before COVID, Fermilab was open to the public. You could
Oh,
just go
wow.
there. Um, Day in the life. When I graduated from the University of Illinois in 1983 and started my job at Fermilab, I was hired to help build the very first antiproton source in the United States. CERN had built an antiproton source. So this is a particle accelerator that not only creates antimatter, it separates it and stores it for hours.
Oh,
So
wow.
it was a trial by fire for me because I had to learn high vacuum technology. I learned, I mean, I spent the first 2 years just being flooded like a fire hose with information, learning how to be a mechanical engineer. When you graduate from any university, you're not a very good engineer until you start building stuff. And Fermilab was perfect because I got to build hundreds of things. My website documents a lot of the things I built at Fermilab and everything I've built since Fermilab.
Oh,
Well, I
wow.
want to talk about the horn. Tell me a little bit about it's the neutron horn. Is that what
Uh,
it?
and,
Neutrino.
and before you tell us about the horn, the anti-protons, is that just like two down quarks and an up quark that are stuck
What
together?
would be two?
Tell our listeners about anti-protons.
So, antiprotons are the mirror version of protons. And if you take a 120 billion electron volt beam of normal protons and collide it against either a nickel or a copper target, we used a couple of different metals. I'm not sure which was the most efficient. About 1 in a million times, those proton collisions on the nuclei of those metals will eject an antiproton. An antiproton has the same mass as a proton, but where a proton is positively charged, an antiproton is negatively charged. And what you have to do then is, so you have a beam that hits the target emits a cone of radiation of all different species, and then you use magnets to separate those species and direct the ones you don't want into a dump, and the ones you do want into the particle accelerator to store in a vacuum vessel where they can't touch the walls of the vessel or they can't interact with any gas atoms that are left in the vessel, or they'll annihilate and they'll be
Right,
gone.
right. That's like the world's greatest science fair project.
Oh, it was fantastic. I loved every minute of it.
And how at what point in your career did you build that world record? I'm going to use the word horn for lack of more
Neutron.
articulate language.
It is a horn. Everybody calls it a horn. I joke that I'm world famous to about 40 people who know and work with horns.
Oh, we're about to double that with this podcast.
Double, if we're lucky. Yeah, but I'm fascinated to know. So, first of all, you have so many things that you've developed, right? So, I want to hear about this more, but like, just thinking, you must be constantly being hit with visions or something that you ultimately then create. So, start with the horn.
Well, so a horn. I didn't invent any of this. As a matter of fact, I have a picture on my wall outside the door of Simon van der Meer, who invented the horn, and he won a Nobel Prize for it. What I did was, horns were used in particle physics experiments back in the 70s, and then the early horn builders, Simon and the generation who came after him, they were gone. And when we needed new horns for new neutrino experiments at Fermilab, we had to basically redevelop the technology. And it's a pretty simple idea. You take an aluminum pipe that is one size. Actually, the inner aluminum pipe is about the size I'm showing you with my hands. And then outside that is another pipe, and you connect them at one end. So they're electrically connected at one end, and they're connected to a power supply that is as large as a building. on the other end. And the mini boon horn pumps 170,000 amps of current into the center conductor, which then wraps around to the outer conductor, and it sets up a magnetic field in between the two conductors that is a 1/r field. It's an inverse R field. So the farther away from the center of the horn you are, the less kick you're getting as a charged particle. And what it is it's a flashlight for charged particles, because again, we're taking a proton beam. In the case of mini boon, it's an 8 billion electron volt proton beam, colliding it against a beryllium target. A cone of pions and other particles are coming out of that target, and the horn's purpose is to get the charged particles all moving in the same direction down a decay channel so that they will decay into neutrinos moving in the same direction. Because once they've decayed into neutrinos, you can't affect their trajectory. Nothing in the universe except gravity pretty much can affect their trajectory.
Wow. Don't we have neutron detectors deep within, like, miles underground, because they just pass through the Earth?
Neutrino detectors.
Right.
Not neutrons. Neutrons
I'm sorry.
As a matter of fact, we have a variety of neutrino detectors. There is a giant cave of water in Japan for the T2K experiment, where the walls of the cavern are aligned with photomultiplier tubes, and they pick up neutrinos from all over the universe, supernova neutrinos. As a matter of fact, people are now combining neutrino astronomy, optical light astronomy, and radio astronomy to be able to look at events like a supernova. The neutrinos get here first.
Whoa.
When a supernova happens, the neutrinos get here before the light, because in the nuclear reactions in the sun, neutrinos can escape a star's core where the photons from the fusion reactions can't. They're trapped by the density of the matter. It's very hard for photons to get out of, and a supernova involves the ejection of lots and lots of material. The neutrinos don't care about that material. They just leave. So a neutrino gives you a signal slightly before you get it from the light.
Okay, so the neutrinos don't violate the speed limit of the universe. They just get to leave earlier.
They get to leave earlier. That's it, exactly.
That's outstanding.
There was an experiment in Italy that claimed that neutrinos were traveling faster than light, and it turned out to be a loose connector on their GPS receiver.
All right, now we really are sounding like some of my kids' science fair projects.
No, I was just thinking you've got to bring them in to talk to your kids. And what you have, I can just imagine you must be just any random location. All of a sudden you have this idea. So tell me a little bit about how you are inspired to develop these.
Well, so as a mechanical engineer, especially as a consultant, I've learned over the years that there are different mentalities. Some people have the mentality of an employee, and an employee doesn't necessarily care how long a job takes because he will always be an employee. But a consultant has to always think, what's the fastest way I can do this? And especially you have to think that way, first of all, because your customer never has enough money. But second of all, when you have more work than you can do, you have to be incredibly efficient at doing it. And so physicists come to me all the time. So I've been in business now for almost 30 years. And when I work on an experiment, there are professors on the experiment, there are students on the experiment. Students graduate and become professors and start their own experiments. And they call me when this process happens. So I don't do any advertising.
Okay.
People are just calling me all the time as they want to work on an experiment.
So it's your brand. You have an excellent brand, and you are feeding your future. You're feeding the pipeline. That's very interesting. And I want to ask you a little bit about inspiration, right? We mentioned that you obviously have a lot of inspiration, and you've delivered, or else you wouldn't have been in business for 30 years. I can't help but notice the poster over your right shoulder, the Iron Man 2 poster. As someone with both a physics and engineering background, I have two brief questions. Number one, what's your favorite movie or Marvel or movie scene? And second, where in the Marvel movies did you most go, that so violates the laws of nature? Which one of Iron Man's moves do you go,
I love Tony Stark. I love Iron Man, but the physics of Iron Man is terrible.
It is, right?
It's terrible. I study the scenes where he's getting into the armor, and I notice those intricate little mechanisms connecting, and I'm realizing this armor has no strength whatsoever.
Yes. Well,
And probably the worst scene is when Tony takes a tank shell, because that is so completely ridiculous.
yes, Newton's laws, right? It's like Newton's
But
laws and the G's that he pulls, right? He would be soup. His body would have been liquefied
oh,
inside
absolutely.
the armor if it had survived. But you know what? I love the Marvel movies as well. And I like the fact that they promoted an engineer, right? An engineer who was a problem solver as the lead guy for a decade. So,
Oh yeah. Um, Even his first flight out of the cave in Afghanistan, you don't survive that kind of landing.
no, the impact, right? That's like 100 G's or more. So, yes. Yes, I totally get that. So let me ask this: your company, have you had some employees in your consulting company? Are you a large operation, or do you have other consultants that are your subcontractors? And if so, have you had folks with you for a long time, or how is your business model set up?
That's exactly how my business model is set up. The last thing you said, I have never had an employee.
Oh
I
wow!
only have subcontractors, and most of my subcontractors have been with me 20 years or so.
Oh, you have a very good setup.
Yeah.
Have you ever worked on any thing, maybe spacecraft? We know that you're in the world of particle physics, but have you ever built any detectors or hardware that's been put on a satellite?
No, no, nothing's been put on a satellite, but uh, just by chance, we have a cabin on the Upper Peninsula of Michigan, and I rented, because I'm an entrepreneur, you don't often get a real vacation. I rented office space up there. And when I rented office space up there, I met people through that office space who told me that there was a space-based business in Houghton, Michigan. There's a company called Orbion Technologies that makes Hall effect thrusters for satellites. And I forced myself on them and, and called them up and asked for a tour. And so one Saturday morning, about a month or so ago, Jason from Orbion gave me a fabulous tour of the facility and pointed out a problem area that he has. It takes them too long to connect the Hall effect thrusters in their vacuum test chamber. So he wanted somebody to automate that. I can do that. I know how to do that. We haven't made a deal yet, but I'm hoping that that will happen.
So you're a problem solver. That's really what your job is to take where there are areas that can be improved, or to figure out how to, you must ask a lot of questions or come up with those answers.
Well, yeah, you have to ask a lot of questions.
Yeah.
One of the things I think I offer my customers is they tell me what they want, and I tell them what they need.
You also tell them what they can afford to pay for. So,
Yeah, yeah,
um,
that actually was a big part of the mini boon experiment. In previous neutrino experiments, there were multiple horns in series. Mini boon couldn't afford multiple horns, so I had to work with a physicist friend subcontractor, and we had basically designed shootouts of various designs to come up with a single horn that would do what mini boon required.
now, did you have to prototype that, or just you drew it up and you built it and it worked? Is it?
We 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 always call the first one we build the prototype, and when it works, it's the production model.
Got it. Very smart. You cut your production costs in half. Um, just curious, before COVID, we were invited to something called the Michigan Space Forum that was in Traverse City. We went up there because there's a company called Atlas Space Operations, and it's a retired Air Force general, Mike Carey, nice guy. Our kids went up there. We had a blast. So I know people don't often think Michigan does anything with space, but
Yeah.
they want to. They actually want to launch from up there.
Yeah.
So,
There is a rocket grounds on the Upper Peninsula of Michigan. On the Keweenaw Peninsula, there's an old rocket launching ground. I don't remember exactly what the history is, but there's still a historical marker for it.
well, that's outstanding. Let's pivot just a bit for a moment about your role in the National Space Society. I know for our audience, I know Larry because he is a certified grade A space ambassador, right? It's a very coveted title we aspire to, where we get a laminated card that's good for a couple of years, and then we have to return it to Mr. Steven, or he gets hot. What can you tell us a little bit about the Space Society and your role in it, and as a space ambassador?
My whole public speaking career started because a friend of mine asked me to come to her class and talk to her fifth graders because they wanted to know things about rockets and black holes and supernovas and all kinds of other things. So I started to write a series of general science talks appropriate for fifth graders. And it turns out if you've done it for fifth graders, it tends to be appropriate for almost anybody.
Yeah.
That's the general public.
Yeah. Yeah. So I started doing talks to fifth graders, and then I know Jim Plaxco from the Chicago Society for Space Studies, and he set up the Speakers Bureau from that chapter. So I gave some talks to CSSS, and he invited me to be on the Speakers Bureau. And what I do is I've written a number of talks on the space elevator, on the work that I've done on the space elevator. I've also written most recently a talk on the Sloan Digital Sky Survey because I helped build that telescope in New Mexico.
Very cool.
So just stuff that I know or that I work on.
I'm thinking, right, I'm part of the Missile Space and Range Pioneers here. It's basically up on the Space Coast of here, Florida. But if it's okay with you, I'd like to share your name with our president because we're always looking for speakers, and you would be definitely fitting that bill, I know. So you probably have a million things to talk about.
Yes, I appreciate that. Yeah, likewise, we're active. Have you ever been, are you aware of the, I know you're in several, like the ASME, and you're in the Professional Society for Welding and some others. Have you ever considered joining maybe the AIAA? Because I know you're not pure aerospace, but so much of what you do intersects with, the companies and the folks in those domains as well.
I would certainly consider it. I've got a book here that I'm pretty sure was a AIAA study on the space elevator somewhere around here.
I feel like you should be on a technical committee with the AIAA. That's you sound like somebody with, we have a friend in our section of the AIAA down here, and he is a really good nuclear space propulsion expert, and he works for Aerojet Rocketdyne. You remind me of him. I feel like you should be on a technical committee with the AIAA, and I think you would enjoy the camaraderie there as well. So
that sounds great. That sounds
well, great. As our last question, we usually ask if you have any imparting words of wisdom. And, our listeners are mostly the students that we work with who love space in general, but we have some educators as well, just kind of inspiring, kids, the next generation. So as far as if someone wanted to go into a career in engineering, any advice for those students or just in general?
Any advice in a 30-second nutshell? I had a professor at the U of I, R.E. Klein, great guy, and he taught me some key things. Know your game, know who you are, know what your strengths are, and play to those strengths. And and try and figure out whether or not the thing you're trying to do satisfies those strengths or is possible to do with those strengths. If you're not really good at math, you might want to consider another field. You do need some math, but he also stressed to us that professor was the reason I took accounting, and my accounting class was essential in starting a business.
Right.
So do things that are outside your field as well. When I graduated with 2 bachelor's degrees, one was in the College of Liberal Arts and Sciences, which was where the physics degree was. The other was in the College of Engineering. And liberal arts and sciences forced me to take Chinese history, ancient Greek history, and those were absolutely fascinating. I really enjoyed those. So many of the engineers complain about social science and humanities requirements, and I never complained about those.
I'll be candid with you. As a STEM person, I found it a nice respite to get a nice social sciences class that was a different part of your brain, right? Maybe you write a paper, but you're not crunching numbers the whole time.
Well, I personally think the students now and even of the future, it's not going to be just left or right brain. We have to be able to nurture both sides. That's really kind of where I come in and play with this is he teaches them the content, but I teach them to talk about it. right? And so to be able to have those engineers of the future who are not only brilliant in their content area, but to be able to share that with others, I think is important.
Yes.
We want to thank you so much for spending some time with us today. And I hope you don't mind if we reach out to you again in the future, just if nothing else, for some connections and some questions.
And we will share any links that you've provided us. We will share them with the info on the podcast.
Yeah, they're in the show notes. I've got his link to his projects that he's doing and the website for your company as well.
And again, Larry, thank you for the time. I really enjoyed it. And as soon as we finish this podcast, we can talk about Star Trek some more.
This was a lot of fun. Thank you for inviting me.